here. So apparently, we know a little bit about geothermal. I'm going to be the lead here. I've personally had geothermal in my house for 41 years. So admittedly, over the years, there's been leading edge technology and cutting edge technology. And I think we're past most of the leading edge, the technology. We're up into the coefficients of performance, up into the 5s, 6s. That means for every kilowatt in, you get 5 or 6 kilowatts of heat out. So very efficient, very advanced, more advanced, compressor more advanced, new refrigerants, new controls. So manufacturing got expensive, minerals got expensive, equipment went up drastically in price, installs went crazy. We're not installing them for $16,000 anymore. But Efficiency Manitoba came to the table and said, listen, we're going to give you some money to help you pay for the system. So that's going to be talked about as well tonight. So very exciting times where there's nowhere in North America where there's one stop, but only one other spot in Canada that offer any type of incentive like this. So working with them has been a pleasure. So our panel is Clarence Yonker from Southern Company Mechanical Incorporated, MGEA Chairman, Chris Celebro of Gem Equities, also board member, Jerry Karate from Paradise Geothermal of Benray. What are you doing? 1,100 fuel installs. He's about to learn how to do it soon. Peter Fair does drilling, vertical drilling, he's going to go drilling. Doug will talk about his experience as a homeowner and what he's gone through. He's had for 33 years. And then Lindsay Robinson from Efficiency Manitoba said that he personally has his checkbook. No, that's not what I said. I was going to say that. But he'll talk about Efficiency Manitoba and the programs, and then there's pamphlets back on that table just up here in the center. So I'm going to pass this over to Clarence to give some opening remarks, and we'll get on with the program. Hopefully it's informative.
Thank you, Brent. Good evening, everybody. If you live in Manitoba, you know that choosing which heating and cooling system to heat and cool your home or your shop with isn't a small decision. Our winters are long, and the temperatures can be extreme, and the system you choose can affect the comfort and energy costs for decades. You're all aware of that. And tonight we're going to talk about a technology that many Manitobans have heard about, but fewer fully understand. Geothermal heating and cooling, also known as ground source heat pump technology. As Brent mentioned, my name is Clarence Jonker. I'm the current acting president of the Manitoba Geothermal Energy Alliance, and I've been blessed to be part of the design and installation of many geothermal installations across our province. Now, before we get into how geothermal systems are installed and how they work, it's helpful to take a quick step back and look at how geothermal became part of Manitoba's energy landscape in the first place. Because while geothermal may feel new to some homeowners, the reality is that Manitoba has been a leader in this technology for more than 3 decades. Back in 2002, Manitoba Hydro made an important decision. They formally endorsed geothermal heating systems and cooling systems and began offering power-smart financing programs to support homeowners who installed these systems. This decision, offering power-smart financing loans, helped accelerate geothermal installations across the province. Contractors began learning how to design and install these systems, drilling companies invested heavily in specialized equipment, and homeowners began seeing geothermal or ground source heat pumps as a realistic alternative to conventional heating systems. Remember, this was back in 2002. Over the past 30 years, thousands of geothermal systems have been installed across Manitoba, many of which are still operating today. So Manitoba is actually one of the best places in the world for ground source heat pump systems, just a few meters below the surface. And again, many of you notice the ground temperature stays very stable year-round, It's typically 6 to 8 degrees Celsius, about 8 to 10 feet down. A geothermal heat pump, or a ground source heat pump system, essentially it exploits this stable ground temperature. In winter, the system gathers heat from the ground and moves it into your home. And in summer, it reverses that process and removes heat from your home and sends it back into the ground. And one of the reasons Geo works so well and has such high efficiencies is that it's moving heat rather than creating it. So in simple terms, it uses electricity to move heat from the ground into your home. For a properly designed and installed geothermal system, for every unit of electricity that you use, you can get 3 to 4 units of heat out of the ground. And I've lived in Manitoba long enough to know that if there's one thing Manitobans appreciate, it's getting more heat for their money. As geothermal installations began growing in Manitoba, the industry recognized that the long-term success of ground source heat pumps depended on proper standards, training, and collaboration. And that's where the Manitoba Geothermal Energy Alliance, or MGEA, comes in. The MGEA represents companies across the geothermal industry, installers, drillers, manufacturers, engineers, and designers, all represented in the room here today in various capacities. And our goal at the MGEA is to help ensure geothermal systems are designed and installed properly and perform well for homeowners. We also work very closely with the province of Manitoba and Efficiency Manitoba to ensure that programs support the industry while maintaining strong installation standards. Because ultimately the success of ground source heat pumps in Manitoba depends on homeowners having a positive experience with their system. In recent years, the province of Manitoba has taken additional steps to support geothermal adoption by helping reduce the upfront installation cost. Lindsay's going to go through that shortly in his presentation from Efficiency Manitoba. So through programs administered by Efficiency Manitoba, homeowners can access significant incentives to help offset the cost of installing these systems. The goal of these programs is to make geothermal a more accessible option for Manitobans who are building new homes or upgrading their existing systems. So again, in just a few minutes, you'll hear a detailed overview from Lindsay, and he'll walk through exactly how these programs work. And then there's a question and answer session after, or you can talk to us individually after this panel if you have further questions. So one of the interesting things about geothermal systems is that the most important part of the system is actually underground, where homeowners never see it. Because of that, geothermal projects involve several different specialists in the industry working together to achieve the system installation. So tonight we brought together a panel that represents several key parts of the industry. We have system installers represented here, ground-up installers, district geothermal installers for multifamily residential projects represented here, and a homeowner who has experienced a geothermal system firsthand for over 33 years. Our goal tonight is to give you a clear picture of how geothermal or ground source heat pump systems work, how they're installed, and what homeowners and developers can expect if they choose this technology. So with that, I'd like to invite Lindsay Robinson from Efficiency Manitoba to walk us through the incentive programs that are currently available.
So as mentioned, my name is Lindsay Robinson at Efficiency Manitoba. On behalf of Efficiency Manitoba, I'd really like to thank the MGEA for this opportunity to join you tonight and share a bit of information about the programs that we have to offer, which can support adopting a ground source heat pump. So a little bit about Efficiency Manitoba. So for anyone who isn't familiar, we're Manitoba's Crown Corporation dedicated to energy efficiency. We have more than 40 programs in market available to help all Manitobans from all walks of life, whether you're an individual, a homeowner, a renter, a business owner. Basically, for all Manitobans, we have something to offer. So please don't hesitate to check out our website to see what specific offers may be most applicable to you. But as we look to the future, energy efficiency will be an increasingly important part of meeting our future energy needs in an equitable, cost-effective, reliable, and resilient manner. At Efficiency Manitoba, we really view our portfolio of programs as building an energy efficiency power plant, which can contribute to our grid just in the same or similar way to adding wind power or hydroelectricity. For every kilowatt of hour of energy that we don't consume, we don't need to generate that energy, and that's often the most cost-effective way to support our grid. So, why ground source heat pumps? Well, ground source heat pumps have many benefits for Manitoba. Firstly, they use the stable temperature of the earth and the heat capacity of the ground as a thermal battery. This allows the energy efficient provision of heating and cooling for your home or any building, really. And this energy savings is crucial, but also even more crucially, as we can see today from Manitoba Hydro's integrated resource plan, is the ability to lower what we refer to as peak demand. That is, if you can basically envision the coldest day or perhaps the coldest night leading into an early cold morning, maybe in January or February, when everyone's homes are coming back off their setbacks, people are starting to take showers and cook. That's when our province is collectively drawing the most energy from our electricity grid, and that's what we refer to as peak demand. And that peak demand is really what's driving our need to add new generation, and ultimately that adds a lot of cost for us as ratepayers, as taxpayers, and as Manitobans. So from this chart from Manitoba Hydro, basically in the center of this chart, we're seeing the electric resistance heating and the annual heating cost that a homeowner with electric resistance heating might expect, about $1,600 or $1,700 per year. On the far left, we see the equivalent cost for a ground source heat pump system, about $600 or $700 per year. And this really represents a substantial energy cost savings for that homeowner, greatly improving affordability. At Efficiency Manitoba, we would really like to talk about energy efficiency first. So we encourage an efficiency-first approach which emphasizes the benefit of measures like improved insulation and air sealing first and foremost. This is a best practice because it's best to achieve comfort, energy, and cost savings altogether. Manitoba's cold climate and improved building enclosure really measures, or really typically yields a balance of heating and cooling loads. And balanced loads are really ideal for a ground source heat pump, and particularly when it comes to right-sizing a ground source heat pump. That is, it wouldn't be oversized for heating or cooling. One of the great benefits of right-sizing ground source heat pump equipment is not only will it operate extremely efficiently, but it will do so for many years. Because, again, with the ground as a thermal energy battery, we're not depleting that battery down the road. One of the tools that Efficiency Manitoba offers to help support energy efficiency first approaches is our Energuide Evaluation Rebate. This is a program developed by NRCan which effectively brings a trained energy advisor into your home to evaluate the insulation, the air tightness, all of the different constructions and assemblies which make up your home, as well as the systems which provide heating, cooling, domestic hot water, etc. And that evaluation is really going to identify potential opportunities for you to improve your home, to save energy, and to potentially install a ground source heat pump. On our mass market side, we offer a $4 rebate for those evaluations, and on the income qualified side, those evaluations are fully paid for in full. Okay, so next I'd like to talk a little bit about provided to our existing portfolio programs. They're intended to impact both energy efficiency but also crucially affordability, providing financial and technical support for the installation of ground-source heat pumps, as well as additional energy efficiency measures which can help that strategy. The strategy is a multi-pronged and flexible one across several different customer segments and covering everything from a single-family home to a multi-unit residential building to entire communities. In addition to our financial incentives, the program takes an energy efficiency first approach, as I mentioned, and really emphasizes the benefit of long-standing energy efficiency measures to best achieve comfort, energy, and cost savings. So the Affordable Home Energy Program, or AHEP, is actually a suite of offers, as I mentioned. They're really intended to support the uptake of heat pumps, both air source, but especially for ground source, and also in both a retrofit and a new construction application. So in this slide, you can see the grouping on the left, which is geared towards individual homes, and the grouping on the right targets larger buildings and district systems. We've taken care not to forget about equity. Our income-based offers are available specifically to those with limited income, while our community heat pump program provides First Nation communities with improved access and support to explore these technologies as well. For our purpose today, I'm going to focus primarily on our mass market and income offers. Okay, so a little bit of our mass market ground source heat pump program. For both new construction and for retrofits, Efficiency Manitoba offers an interest-free loan up to $13,500, which is repaid at $75 per month over 15 years on your hydro energy bill. Collectively, this means that up to $38,000 can be covered by Efficiency Manitoba, which equates to up to a $24,500 incentive for the customer. Really intended that many systems which fall under that total cost threshold of $38,000 will basically have no upfront cost to the customer, really providing a great incentive for adoption. It's also really worthwhile to note that in our performance-based home energy retrofit and new homes program, that those programs offer an additional up to $15,000 incentive, which can stack with your ground source heat pump offer. For existing ground source heat pump systems, which are nearing the end of their life, the goal of a replacement incentive is to bring customers to an upfront cost which is comparable to that of a traditional system. So with that in mind, the incentive value is a bit lower, but nonetheless, we want to recognize that market segment and really ensure that installed ground source heat pump systems continue to operate as long as possible, and recognizing the extremely long life of the ground heat exchanger itself. When the heat pump unit itself within the home is nearing its end of life and starts to fail, we're there to support the replacement with another unit. Okay, so in terms of eligibility, it's open to all Manitobans. It must be your primary non-seasonal residence, either installing a ground source heat pump during the new home construction process, replacing an existing electric resistance or natural gas system, or, as I mentioned, replacing an existing ground source heat pump system. And lastly, the contractor must also be registered with Efficiency Manitoba and an active member of the Manitoba Geothermal Energy Alliance. In terms of the steps to participate, the basic steps in this offer are to first find a registered contractor, and the list is available on Efficiency Manitoba's website. Secondly, once the application is submitted, it will be reviewed by Efficiency Manitoba to ensure that all appropriate permits are in place and that best design practices are followed, along with appropriate documentation. Next is the actual physical installation of the ground source heat pump and the completion preparation from the customer. And then finally, you'll start to see that monthly bill and repayment appear on the Manitoba hydro bill. Okay, so let's kind of take a look at that. Let's probably small for the folks on the screen, but apologies for that. But let's take a look at a couple of scenarios which work through how this incentive is structured. So in our first scenario, the total system cost, let's say, is under that $38,000 threshold. For sake of argument, let's say it's $35,000. So the homeowner has that $13,500 loan, and then the $21,500 balance of that system cost is covered by Efficiency Manitoba. The actual full cost, the $35,000 full cost of the system, is paid directly by Efficiency Manitoba upfront to the contractor. So in this case, the customer has absolutely no upfront contribution. You're simply repaying the zero interest loan on their hydro bill for the next 15 years. In the second scenario, let's say our total system cost is above the threshold. It's now $50,000. In this case, the same loan exists, and the maximum incentive amount of $24,500 is reached. Again, the $38,000 is paid directly by Efficiency Manitoba to the contractor, but in this case, the balance, in this case, $12,000 of that system cost must be paid by the customer to the contractor when the installation is complete. Okay, just before I move on, I wanted to mention that multi-unit residential buildings present a really unique and powerful opportunity for many Manitobans to benefit for geothermal technology. As such, we're offering special bonus incentives for these building types in our commercial retrofit and new construction programs. If you're a MERV owner, a developer, or otherwise someone who's connected in that world, please don't hesitate to reach out, get in touch, and we can absolutely share more details on those programs and how to participate. This is an extremely attractive offer. If I were building a building today, I would absolutely be trying to take advantage of it. Okay. And next I'll move to our income-based offers. So under our income qualified umbrella, we have two primary programs. The Energy Efficiency Assistance Program, which is available to homeowners, renters, landlords, social housing providers, and First Nation households. And our second main program, the Métis Energy Efficiency Offers Program, which is specifically for Métis citizens. It's delivered in partnership with the Manitoba Métis Federation to support low to moderate income Renderer Métis citizens, being homeowners, renters, and landlords. So under both of these programs, they actually support a wide variety of energy efficiency measures. All of the qualifying households will receive a free home energy evaluation. That's the energetic evaluation that I mentioned. And this is really intended to help identify those most suitable measures which would be eligible for full coverage, but which are also specific to each individual home, recognizing that each home has individual characteristics and needs. Such prerequisites like insulation and air sealing, energy savings devices, smart thermostats, and replacements for your heating system, which now includes the ground source heat pump option. So to be eligible for the Energy Efficiency Assistance Program, you must fall within some specified income threshold brackets, which basically vary depending on the number of people in your household of an income generating age, probably older than 18. When applying for a rental property, if the property is a rental property, the landlord is actually the applicant. However, the income thresholds are met by the tenant's income, not the landlord's income. So it's a bit of a more complex eligibility scenario. For our Métis energy efficiency offers, it's very similar. It provides the same retrofit options with some differentiating factors. Firstly, the income qualified thresholds are slightly different, but these were developed in alignment with the MMF's HELP program. So that's why it's slightly different. It lines up there. The other key difference is that we have an agreement with the MMF that they will actually pay that heating system loan amount rather than it being added to the Manitoba hydro bill. So that has an extra bonus for Métis citizens. Across our income qualified offers, there are some additional eligibility criteria. So firstly, these offers target electrically heated households And this is really because the intent is specifically to focus on energy affordability in tandem with energy efficiency. Despite the exceptional efficiency of geothermal systems, the relative pricing today of natural gas and electricity means that gas customers would likely see either small savings or potentially bill increases, which would negatively impact affordability and defeats the intent and the purpose of the program. From a practical perspective, eligible customers must also have sufficient unobstructed space on their property for a horizontal closed-loop grounding station. And including only this particular system type, at least initially, is a decision that our program has made, which is intended to target the most cost-effective option, delivering the best value for the program, but which is ultimately funded by Manitoba Hydro ratepayers and by the federal government. So there are cost-effectiveness considerations that do drive some of the program decisions. Okay, and then the EAP and the MEO, that's the income qualified programs, in terms of their steps to participate, to give you a sense of what that might look like. Once an application is received, reviewed, and approved, the home undergoes the energy evaluation. That's going to identify the suite of potential energy efficiency measures that can be pursued and supported in full. If eligible, upgrades such as insulation and air sealing, which would reduce the heating load of the home, those have to be completed first before an actual heat pump retrofit occurs. So that's really intended to allow the best, most economical and optimal right sizing of that system for the home's needs. And finally, the customer would select a ground source heat pump contractor, again based on our pre-qualified list. And the actual installation would be completed, fully supported financially from Efficiency Manitoba. So with that, I'll close out and just thank you again to the MGEA for the opportunity to join you all tonight. Please don't hesitate to reach out and get in touch with us. Please check out our website to view all of our programs and our details. Thank you very much.
So thanks, Lindsay, for that really thorough overview. As you can all see, there are some very, very meaningful programs that are available through Efficiency Manitoba, depending on the type of project that you're building or your specific circumstance. There's a lot of money on the table through these programs. And as Brent mentioned earlier, it's among the best in North America that we have here in Manitoba as far as rebates and incentives go. So I know there's a lot of information that we went through. I'll open the floor to questions after we've done our panel discussion, and we can go through any questions you may have about that on the incentive side. So I'd like to switch gears and we'll talk about what geothermal installations actually look like in practice. And for that, we have a great panel with us tonight. I'm going to start with a question for Jerry. Jerry Perry has been installing systems for over 30 years. As mentioned in the preamble, he's installed over 1,100 systems during that time. So a definite expert in the field. Jerry, from a homeowner's perspective, can you talk about why proper system design is so important? Why is overall system design important for the geothermal system?
Okay, it's very important that the heat pump is sized properly to match the heating and cooling load of the house. We don't want a system that is too small. We don't want a system that's oversized. So we do the heat loss calculation, and the Efficiency Manitoba will pay for an energy audit, or quite a chunk of it there. So, which is good, because then that's an independent person doing the calculations and stuff. And between their numbers and my numbers, we're usually within about 1,000 BTUs in the calculations. So they're doing it right, or I'm doing it right, one of the two. So anyways, as long as the heat pump is sized properly, and we want to make sure the ductwork is right in the house too, because if the ductwork's not sized properly, we can't get rid of the air. A geothermal will move more air than a conventional system does. With the ECM blowers, when you're doing a retrofit, the ECM blower will counter that because it will ramp up in speed to get that airflow out. So the ductwork sizing is important. On a new install, you size up the ductwork to match that and everything. So, and your ground loop. The ground loop is very important too. I know when we started, we lost quite a few jobs to other contractors that they shorted the ground loop. They came in at a lower price, but in 3, 4, 5 years, you find out that the loop is too short and stuff. There's issues that happen with that. So the ground loop sizing is very important. So anytime I do an estimate, you want to make sure you know how many feet of borehole you're getting, or horizontal loop, how many feet you're getting in the ground, and all that. So that's why with the MGEAs is we're trying to keep everybody on a level playing field, so that we want all the sizings to come in properly and stuff. And because I recommend one size and someone else comes in sizing lower, or another comes in sizing higher, challenge them on it. Ask them why is your system smaller or whatever, and that kind of stuff. So, because we do have sizing parameters that we need to meet, and typically we can size between 70% of your calculated heat loss calculation to 105% of your heat loss calculation. I found my sweet spot is if I'm between 85 and 90% of calculated heat loss with the heat pump output, we're going to have no issues with that unit. It's going to run great. Auxiliary heat will barely kick on and stuff. And in Manitoba, we need a backup heat source. And the backup heat source doesn't have to be because the heat pump can't keep up. It's if there's an issue with it, that you still have heat in the house. Because we do have some fairly complex systems, and certain parts aren't. All the contractors don't keep all the parts on hand. So if a compressor goes, that may be 2-3 days to get a replacement. So in the meantime, we still have to have heat. We can live without cooling. We can't live without heat in Manitoba.
Awesome. Thanks, Jerry. So yeah, system design. You're definitely well versed to speak on that. I guess Jerry is one of the most experienced installers in Manitoba. How do you determine what type of ground loop goes in for any new system?
Yeah. Basically, it depends on the site conditions, your site size, and if you're in rural area, we can do horizontal loops if we have the area to do it. Typically, if you're doing horizontal, we'll have multiple trenches of between 250 to 300 feet in length. So we need to have space to do that. And then the trenches would be roughly 10 feet apart on each one. If we're in a town or city, typically we need to go vertical because we don't have the footprint to put it in. So vertical, we'll drill them down and do that. In my area, we don't do well to well because we don't have the water quantity or the quality to run through a geothermal. In Winnipeg here, the water quality and quantity is very good, so there's a lot of well to well systems in the city area. So, but where I am, that's not feasible at all. So.
Perfect. Thanks, Jerry. So the next question here is for Peter Fair. Peter Fair is a vertical loop installation company. He owns a vertical loop installation company in Manitoba. He's been installing vertical loops for many years. Peter, one of the most unique parts of a geosystem is the ground loop installation. For homeowners who may have never seen this installation process before, can you walk us through what a typical vertical loop system installation looks like for, let's say, a 2,000 square foot average home on a reasonably sized lot? Just give us a bit of a scenario as to what that might look like.
So it's been determined that we're going to do a vertical loop. It's generally because you don't have a lot of real estate. So the rule of thumb is 250 vertical feet per ton, but again, that's where the calculation comes into play. But the first thing that I tell customers is I'm going to destroy your lawn. When we come in, we drill anywhere from in Winnipeg 75 feet to rural areas where we can drill 250 feet vertically with a smaller equipment. And so then once we've drilled the loops, the pipes are shoved into the hole, we grout them according to the CSA standard, and then we have to excavate and tie all those loops together and come into the building. And so during the drilling process, we drill a fluid and there's lots of mud. And when we excavate, we tear up your lawn to tie it all together. So that's the biggest expectation, is that you will have to do some landscaping when we're done.
Thank you. So while you're drilling, you mentioned that you grout the holes during that process when putting in the pipes. Can you give us an explanation of what that is and why it's so important?
So the holes are typically drilled between 4 inches and 5 inches in diameter, and the pipe is inserted to the bottom of the hole. And so there's a void. And that void, there's 2 purposes for grouting. That void eliminates contamination of water. So if we grout it with a bentonite, a sand solution. The bentonite swells and creates a barrier for any groundwater contamination, as well as now we have that thermal conductivity from the pipe that's been inserted to the ground that creates the source of heat.
And I guess for the same typical installation, how long would you say the process would usually take? Again, for about a 2,000 square foot home, if it's not raining for weeks on end, what's your general timeline?
5 working days.
Okay, thanks for that. Next question is for Chris. So Chris Snellgrove is with Gem Equities. He works with a lot of developers on multi-family residential projects. I'm not sure if we have any developers in the crowd. But just Chris, can you comment on district geothermal systems briefly? And why should developers consider installing district geothermal systems when they're planning multi-family buildings or mixed-use development buildings?
Well, the first reason for multifamily use is the same reason as for residential. You're going to save money in the long term just on operating costs. Anybody who owns a building, that's key to everything, is get your operating costs down. The other reason is it will increase market appeal because of the increasing interest in having green operating technologies. So we're actually getting more demand for that. Another factor is simplification of mechanical systems. Geothermal system is actually pretty simple, doesn't take up as much space in the mechanical rooms as having boilers, and chillers, and rooftop cooling units. So they can simplify things in that regard. The other thing with the district, depending on how it's done, which is how we do it, is the loop. It can be a long-term revenue asset. You install that, you maintain that, and charge for its use in a district system. That's kind of it in a nutshell.
Okay, thanks, Chris. District geothermal systems are commonly spoken of in Manitoba. Many of you may have heard of Waverly West as moving in that direction a number of years ago. Are you seeing in general an increase in the demand or request for information on district geothermal systems, specifically for multi-family residential buildings in Winnipeg?
Well, we are seeing an increase in inquiries, and I think that's largely due to the Efficiency Manitoba incentives, because as a building owner, you can get some significant money back. When we first started doing this, we would have to kind of beat the bushes for people that wanted to do it, and now they're coming to us. So that is quite the trick.
Perfect. Thank you. Douglas Hildebrand has had a geothermal system installed in his home for 33 years. Douglas brings a really unique perspective to our panel. We're really grateful for him to join us with his perspective. Douglas, can you share a bit about what the installation was like for you and how the system has performed for your specific application?
Good evening, everyone. As mentioned, I've been heating, cooling, and providing the electrical hot water in my home with a geothermal heat pump for 33 years. Originally, when I built my home, I installed straight electric heat. I live in a rural area, so I didn't have any other options. I went with straight electric, and it did okay. Managed to keep the house warm. Had some interesting bills. Then along the way, geothermal came along, and I took an interest in that. Did some research, saved some money, and eventually converted over to a geothermal heating system. My costs are now 25% of what I paid previously. So I'm saving 75% less on my heating bill. That's amazing. These savings result in how efficiently the geothermal system uses the electricity supplied to it. With an electric furnace, when I had my electric furnace, and a lot of my comparisons will vary from the electric furnace to the geothermal, with my electrical heating system, it was 100% efficient. That sounds pretty good because every dollar I put into that electric furnace, I got $1 worth of heat out of it. Seems like a pretty good deal. Recently, I had my existing geothermal system tested to find out what the operating efficiency is of that unit. It is 450% efficient. So every dollar I put into that geothermal system, I get $4.50 worth of heat. Seems like free heat to me. That's where the savings come from. My home has never been so comfortable with geothermal heating. My old electrical furnace had this, when you set it, I'm going to use old temperatures here, 70 degrees, just because the numbers work a little easier. I would set it at 70 degrees, and then you'd feel a little chilly before the heat would come on, because it's got to go down to 68 degrees before the furnace goes, oh, I got to make heat here, and then it starts giving you heat, and then it doesn't shut off until it's 72 degrees. So you have this temperature swing that makes you feel really, really comfortable when the furnace shuts off, but from the whole time after it shuts off till it comes on again, you're cooling down. Well, the geothermal system has this magic in it that it's able to sense the amount of heat load required, and it puts it out just enough to maintain the temperature on the thermostat. Every time I go past my thermostat, it is the set temperature. If I pick 70, it's 70 all the time. It can be minus 30, it can be 0, it can be whatever. Always maintains the temperature, no fluctuation. So what that means is, I don't get a chill when the temperature goes down before the furnace starts. Always comfortable. What else was I going to talk about? Set temperature, heating load. Oh yeah. Another great thing happened when I installed my geothermal system. I got air conditioning. Wonderful. Never had air conditioning before, so I don't really have a before and after cost comparison. But the research tells me that geothermal cooling is 20 to 50% lower than your common AC unit. And I believe that. The unit I have cools the house down very quickly and easily maintains the set temperature no matter how hot it is. One great thing, I don't have a noisy AC unit running beside my deck outside making noise while I'm sitting on my deck because it's all underground and all quiet. The money I saved by not installing an AC unit, I invested in my geothermal system to kind of bring down the cost on that. So plus I only have one piece of mechanical equipment versus having a separate AC and a separate heating unit. Oh, and I never have to call the AC guy to come and fix the unit either. Hot water. My geothermal system has a hot water heating circuit that is connected to my hot water tank. I had the opportunity to install some monitoring equipment on the hot water tank just to determine how often it was coming off and on. It never came on. It doesn't come on unless you do multiple loads of laundry, then the elements on the hot water tank will come on. We've gone away on vacation, and I just got this habit, I turn breakers off, pumps and whatever when we go away. We come home, I didn't even turn the breaker on the hot water tank, and I've got hot water flowing out of my taps. So it is just amazing. I would guess by the monitoring I've done, it probably supplies at least 90% of my hot water for my home. So that's my experience. It's been very positive. Like I say, the comfort end of things is just amazing. And as far as longevity goes, I've been in it for 33 years and still cooking. So I'll let you know when it's all said and done what it looks like. Thank you for your time.
Douglas, thank you so much for that perspective. One of my follow-up questions is, would you make the same decision again to install a geothermal system? But I think you just very vividly described that you absolutely would, so thanks for sharing.
Yes, I definitely would.
Okay, so that brings us to the end of our panel discussion. We'll open the floor now for any questions that you may have. Feel free to ask any one of us, or just ask in general, and we'll try to handle any questions that you may have. There's 2 microphones set up here, so feel free to come on up to the mic. Or it's a smaller crowd, if you're more comfortable just raising your hand and speaking, that's fine as well.
I'd like to do a song.
No problem.
On the sizing, you talked about right sizing. Am I correct to assume it's because you want the pump to run continuously? Is that why too big, too small? Is it, like, why would a system that's too big not be good?
Okay, well, now on the sizing there, the heat pump system will run longer cycles and stuff, so that's because typically we match the load to your heat loss. So typically with a gas or electric furnace, well, you've got your options of sizing, and typically they are sized about 50% larger than required. So they will cycle a lot more. We want the heat pump to run longer cycles and not turn on and off as much. And that's where we get we keep that temperature very consistent in the house then.
So it is about keeping the pump running more than off, on, off, on, off, on.
Yes, yeah. Turning on and off is the hardest thing on motors. So the longer cycles they run, the better it is for them.
That's what I was assuming, that right sizing was important.
Yes.
Thank you.
Yeah, thank you.
And just more to your comment about what's so wrong with oversizing a geothermal system. It's very inexpensive to oversize an electric furnace or a natural gas furnace. Whether you put in a 100,000 BTU natural gas furnace or an 80,000 BTU natural gas furnace, the difference on that model is maybe $80 to $150 on a wholesale cost, and there's no ground attached to it. When you install an oversized geothermal system, the difference from a 4-ton to a 5-ton, for example, is thousands of dollars just for the equipment. And you also need to make sure that capacity is installed in the ground. So you just take an increase, even a small increase of one ton, and you increase your cost dramatically for no need, for no added efficiency. Thanks for the question.
Yeah. If you're in the city and you put in a ground source heat pump, how close can your neighbor put one in? Like how much area do you really need for each one?
So the question is, if you're installing a ground loop system in the city, a ground source heat pump system in the city, how far away do you need to stay from a neighboring ground source heat pump system? Did I capture the question?
Yes.
Peter, I think you're best suited to answer this.
So typically, you have to be, according to say, 5 feet away from your neighbor's property. So that gives you 10-foot spacing between the holes, and that's typically what we do. The heat radiates approximately 5 feet from a borehole. So if you're 10 feet apart, then we have the ability to extract the heat without losing your heat energy to your neighbor.
Yeah.
So 5 feet from your property line on both sides.
But if you had like quite a few neighbors having it, would it cool the ground, or would the heat come back into the ground?
Again, the heat would come back into the ground.
It will.
Yeah, so because we have cooling and heating load, typically a ground loop will get colder as the season goes on. Like in February now, we'll have ground loops that have dropped 5 degrees.
Okay.
But we also have a ground loop for your air conditioning that'll increase the temperature by 3 degrees. So that fluctuation goes back and forth. And as long as we have that 10-foot buffer from one borehole to the other borehole, we have enough. The heat transfer won't be extracted from your neighbor.
Okay, very good. Thank you.
Thanks for the question.
Could you give us an idea of, what a rough system would cost? I mean, we can just use generic, like assume 2,000 square foot home. Let's say you've got, decent acreage to do a horizontal loop. Maybe it's, electric forced air. Everything else is in pretty good shape. Can you give us a sense for, where the cost is and roughly what it might look like?
So that's converting an existing home from an electric furnace to a geothermal system. The home is roughly 2,000 square feet. Jerry, are you able to give some ballpark figures as to what that might cost?
Okay, on a horizontal loop, 2,000 square feet is going to be roughly about a 5-ton unit. You're probably going to be running, with a horizontal loop, it's probably going to be running about $45,000, roughly in there. If we go with a vertical system, that's going to push the cost up to $55,000, $58,000 with the vertical system. So.
And how do those costs break down roughly? Where is the cost, versus the outdoor underground work versus the inside?
Typically, if it's a vertical system, the equipment cost inside is just a little bit more than the ground loop costs. So on a vertical, they're very close to 50-50 on there now. The horizontal, being cheaper to excavate, your biggest cost is your equipment and stuff. So.
What are you seeing for timelines from application to approval?
So the question is, what are the application approval timelines for Efficiency Manitoba?
Yeah, you know what? I honestly don't support the ground source heat pump directly processing the application, so I'll have to get an answer back. But perhaps some of the folks who do participate from the contractor side can give their perspectives.
Typically, from once we submit the paperwork, they're usually pretty quick. It's usually about a 1-week turnaround. Yeah. So that was one of our concerns with that is we didn't want to have long turnarounds because customers want to know and we have a short window for installation in Manitoba. So when we get the applications in and stuff, if we can get going on it, we want to get going as soon as possible because right now it's a little tough to put in a ground loop right now. So our window starts mid-May to end of October sometimes. So thank you.
So this program by Efficiency Manitoba, specifically the mass market program, which is the $38,000 that's eligible to every Manitoban regardless of the system that they have, whether it's a new home or whether they are replacing it. That was rolled out last fall, and initially there was obviously scrambling and a bit of a rush by the market to get applications in, and the processing time was 3 to 4 to 5 weeks as we worked through all the various requirements that were required for the application process. But if the application is complete now and submitted, a 1-week turnaround time is possible.
Okay, so if I'm going to have a new bill, when do I apply? At what point?
If you have a new build, actually, Jerry, do you want to? Yeah, maybe we should have this.
If you have a new bill, you make the application as soon as you have your plans. There's also a Power Smart program or new home energy new home program. So, and these are stackable on top of the 38,000. So the new home program, you can get up to a $12,000 incentive from them too. So then geothermal, there's a portion of that the geothermal kicks into and stuff. So typically on a home, the geothermal, adding geothermal will be about $4,000 to $5,000 just for that portion of that on the new home. So, but the new home program you have to apply as soon as you know you're going ahead or whatever, get that application in because they have to model that one, and there's a little more paperwork involved with it and whatever.
So once there's stamped drawings.
That's the short answer, yeah. As soon as you have stamped drawings, pick your contractor, go through the process, and you can start that right away.
And I'll add on to that as well. You know, with our new homes program, the energy modeling aspect that Jerry mentioned is a real key one. You may have your drawing set basically produced, but that energy modeling is going to give you a sense as to where energy is used within your home by that design. And you might actually decide to, oh, well, perhaps I want to go to the triple pane windows because it's going to get me X dollars more incentive. And yeah, that incentive goes up to $15,000 for that new homes program, which again, yeah, stacks right on top of the ground source income offer as well.
Thank you.
Thanks for the question.
What about system failures in it? How would you be able to handle it if it did go down? How quickly would you repair it? I mean, you're talking about a big loop, possibly something happening in something in the loop. It's a little bit of a concern in that respect. We haven't had any trouble with it. George,
I can comment. It comes with a backup electric heat installed in it. If the system goes down for whatever reason, the electric will pick up on it and look after you until you can get it repaired.
Great.
I can speak to the loop end of it. We have a 25-year warranty on any loop that's installed. That's mandatory as well. But the pipe is rated for 100 years to ground. As long as there's no ground disturbance, that loop is in there for the next 100 years without any failure. Like stringent quality control for the pipe, as well as before anything is buried, we pressure test it to 100 psi. And so failure rate is almost nil for the ground.
I'll add to that is, knock on wood, but I have not had a loop failure yet.
This is for Peter, and it's area specific. I'm looking at property out in the Birds Hill Park area, which is the sandier soil, and there happens to be a hole excavated in the property that's about 10 feet deep, and it's still sand and gravel down there. Obviously, a closed loop system would be the less expensive to do, but I do have to do a ground well in any event. I understand there may be a problem with heat transfer in sandy, dry soil.
There's a problem with heat transfer if you're doing an excavated slinky style ground loop. But if you're drilling a water well, you can actually do in that area we do what's called a 2-well system. If you're already doing a water well, just add a second well. It gets pumped from one well through your heat pump. You can use it for your domestic water, and it goes back into the ground.
So, but that's also can be hard on the heat exchangers within the furnaces, right?
It can be hard. What I recommend is that you use a heat exchanger in between. It's a small extra cost. So there's a heat exchanger that the groundwater goes through first, and then a glycol solution that goes through the heat pump. Okay. So it's to add a secondary heat exchanger with a cleaning. What I recommend, what I do in an installation like that, if the hard water, or if you've got a well that's got hard water, you add a heat exchanger and have it capable of being cleaned, like with valves that you can close it off, and then just put cleaning solution through once a year, and your ground, so your heat pump will never have an issue with corrosion or failure. It's just an external heat exchanger that just has to be replaced maybe every 15, 20 years, or if you clean it regularly, you won't have any issues with it.
Okay, so, but I guess I would prefer a ground loop system, but it sounds like I may have difficulty with that in that area. Is that correct?
Depending on the area, we can drill vertically in that area just to about 75 feet. There's also an option of putting like a directionally drilled ground loop. And so depending on the area, we can get down into the sand. And so like Swift that's here as well, they directionally drill ground loops, and that's also an option for that area.
But you are correct, dry, sandy soils do have lower conductivity and need to be studied carefully before proceeding in that direction.
And that would be done, like, would you do sampling of like core samples or something prior to making a recommendation? Is that?
So Manitoba Water Well, like, they monitor pretty much the entire province. I go to their database, and they pretty much tell you what kind of water table you have. So when you apply, like, so they can have a look, and that would be the best place to look is to see what kind of soil conditions you have, and then you can tell kind of through their database as to what kind of would be the best scenario.
So Manitoba Water Well?
Yeah.
And
Yeah.
that's
They work with the University of Manitoba, and so they've got pretty much across the province. I can go into their database, and they'll tell you what the water table is pretty much anywhere.
Do I have access to that database?
You can have access to that. You just go into the water wells. It's public domain. Yeah.
Not the question that I originally came up here to ask, but if it was a water well system, do you have to have a license and pay those annual fees to, who do we pay that to? Water Resources Manitoba. We have a system that
I might be able to answer part of that. The district systems that we do are water well systems. We do require a license through water licensing. I'm not so sure though if it's strict residential use if that's necessarily required. Like the volumes that would be moved are considerably more than residential.
That's correct. For residential applications, it's not required.
Not a requirement.
So the program, if I understand correctly, if I wanted to change my heat source, I would have to have an electrically heated home.
So it does differ between our mass market and income qualified offers. So it depends on which one of those market segments that you are actually falling into and want to pursue. On the mass market side, we do electric or gas installations. It's really only on the income qualified side that we basically say because of the price differential between natural gas and electricity, we never want to negatively impact the energy affordability of the income qualified customer. So therefore, we only use electric on the income qualified program side.
So if I had a gas system, change the heat source to geothermal, would the supplementary system, could it remain gas?
Likely wouldn't, I would say. I think the vast majority of ground source pump systems will come with some form of integral electric resistance backup heating.
It's built in the system.
Yeah, and when you're talking about dual fuel systems, typically those don't operate in tandem. It's going to be one or the other. So I think if you were a gas customer, likely you would be fully on fuel switch.
Thanks for the question. Yes, sir.
Yeah, with your heat system, can you also hook up to a swimming pool, heat pool?
So the question is, with ground source heat pumps, can they be designed to heat a swimming pool, correct?
Swimming pool, yeah.
Jerry, do you want to take that one?
Yes, we can, but they don't qualify, that doesn't qualify for the incentive.
Yes.
How does your system handle a 3-day power outage?
So the question is, how do ground source heat pump or geothermal systems handle a 3-day power outage?
Well, systems are, you're able to run them on a generator. So, and you don't need a massive generator to run them. You just need a 5 to 10 kilowatt generator, and you could wire them up and you could run it on a generator. Other than that, a three-day power outage, everybody's out at that point. So it doesn't matter if you're geothermal, gas, and whatever. So.
Thank you. Any more questions?
Well to well. Sorry. Yep. I've heard in the past problems with the secondary well not being able to take the water that's being put down it. Is that something that's been solved, or is that a real potential problem?
It can be a potential problem, but again, the driller that's doing the drilling for that, typically that's a water well driller, they would have the data and they'd be able to when they're drilling, they can find out how much rejection, because that you're talking about the rejection well, and they would size the rejection well to make sure it can handle the flows.
Okay, so
yeah, it'll get sized. The rejection well will get sized to the amount of flow that you need. Each ton of heat pump requires so many gallons per minute, and so from the flow side through it, and also the rejection side, so the well gets drilled according to the size that you need for rejection.
And all well drillers know about the capacities required?
Yeah, they'll be told how many gallons a minute we need to reject, and they'll drill the well accordingly.
Okay.
But it does depend on the geology in your area, and it does depend on the well driller and the mechanical contractor working off the same information and designing the system appropriately. So there are factors that need to be taken into account and carefully designed, but a properly designed system in an area where the geology is favorable to a well-to-well system shouldn't hold you back from pursuing that type of system.
If you put an addition onto the house, say in a future date, how easy is it to adapt the system to the additional load?
So the question is, if there's an addition added to a home, how easy is it to adapt the geothermal system? You mean an existing geothermal system?
Yes.
Okay, how easy is it to increase the capacity of an existing geothermal system to handle that new additional load of the addition? Jerry?
If your system was designed for X number size of house and you're doubling the size or whatever, or 50% more, it's going to tax the existing heat pump quite a bit. We have done it and stuff where the existing heat pump is still running and doing that. Their backup heat will cut in a little more often than that. So now, if you wanted to add more loop to it, you can. We have loop maps, so we know where the loop is, but we do have to add more loop to handle that capacity. But the heat pump itself inside is not already sized, so you may have to upsize the heat pump to handle that extra capacity, or use a little more auxiliary heat.
So the short answer is it's possible, but it depends on the situation, depends on how large the home is and the addition that you're doing and your original system capacity.
Can you give an example where the geology is not favorable in Manitoba?
For sure. Jerry, do you want to handle that, or Peter?
Yeah, I guess most areas it's capable if you're doing like a water-to-water situation. In Winnipeg, for example, a lot of lots are not possible because we can't get the equipment into your backyard, and there's not enough real estate in the front yard to drill like wells. And so I think Winnipeg is a complicated area and any town because of the capacity to drill wells, whether they're well-to-well or even like closed loop systems. So that's the biggest, I think, struggle that we have is having capacity to drill when the lot sizes are too small or you're not able to get into a backyard. Without a back lane, the drilling equipment is the biggest issue, getting it in and out. But, well, the geology. Yeah, so, the Canadian Shield is a struggle. So, I think that's probably the only place that we can't do it. Typically, in most other areas, we can either accommodate one or the other, but I would say the Shield is the biggest struggle.
Stonewall might be a challenge too.
Stonewall, yeah, we've done a lot of wells there.
One of the reasons that Manitoba has the highest number of geothermal installations per capita is because we're blessed with such good geology that lends itself to geothermal systems. So if you have thick, heavy plastic clay in your area, the Manitoba gumbo, that's prime. If you have sandy loam, then maybe we can look at a well-to-well system. There are various options available to you. But yeah, one of the most challenging areas is the Canadian Shield, some of the northern communities, and in Whiteshell. Maybe we can do lake loops in those scenarios. But generally, there's a loop option that works for you, just not in some areas of the Canadian Shield.
Thank you. How far apart are your well-to-well water systems? Where you're using the wells to each your home?
So the question is, when deciding to use a well-to-well system, how far apart do the supply and return wells need to be? Peter, do you want to handle that?
Typically, they like them to be 100 feet apart, but we have done it less, again, depending on the geology, and that's where we go to the Water Well Association loop map, and so we can do it as close as 30 feet.
So I'm assuming that there's no freezing problems, like they do that all 10 feet down for like this.
Yeah, everything is excavated below the frost line. So, yeah, typically the connections are made below the frost line, 6 to 10 feet, depending on the area. And those connections are just like a regular water well, and then the rejection well is the same.
Yeah, good question, thanks.
Peter, you made reference earlier about how condensed spaces might be, and maybe you can't get your equipment in there. Has there been any consideration or actually examples of where maybe you've leased land or taken an easement of an adjacent property to install a system to supply maybe one user or multiple users? And further to that, when an area of the city is being developed, maybe a question for you from Jim Equities, do you consider installing the infrastructure, say, in roadways while they're building the roads so that it's there? I'm not sure whether that's actually where it goes or maybe it's in public reserve areas or boulevards, but is that something that's being considered as well, to have it
You've asked a couple of questions there, and in our district systems, we have one case where we had a well on city property that we obtained permission from the city for that and got an easement to get our infrastructure to that location. So that is something possible to do. We're currently designing a larger system, and we are trying at this point to work with the city to do exactly what you said and run our main lines in the right of way for the streets. No different than you would have a water main, well, we would have a geothermal main. So that is something that we are looking at. We're trying to work with the city to do that. And there's some challenges with that because with any bureaucracy, when you try something new, people kind of flip out because like, well, we haven't done that, we don't do that. How is that possible, right? So it is something that we're working through.
Thank you. Thanks. Any final questions?
Do you have different heating zones in the house with a geothermal system?
So the question is, with a ground source heating system or a geothermal system, can you have different heating zones? Jerry, I think you're queued up for this one.
Yes, you can. There are zoning systems that you can use for that. That work has to be designed to handle the flows and that. Typically, what I've found in most houses is if you run your fan on continuous, your temperatures don't vary very much from main floor or basement and stuff. So typically, we run the fans on continuous all the time and stuff to counteract any temperature differentials in that. So.
Thank you.
On that note, combining the furnace, air furnace to heat the house and in-floor heating in the attached garage, is that achievable?
So the question is, can you use geothermal systems to heat your home and your attached garage?
Yes, there is equipment available for that. I've had one in my house for 26 years now. And we heat the basement floor and I heat the garage. And that's easy to zone differently. So I keep my garage, it's at 15 degrees all winter. My basement's warmer in the basement than it is on the main floor. So you can run that through that way and stuff. And it works very well.
Question.
I'll just add on to that, just to make sure everyone's aware that when it comes to Efficiency Manitoba incentives, it's really only those primary occupiable living spaces which are eligible for the incentives. So you wouldn't get the portion of the system related to heating your garage paid for.
Oh, I'm going to live in the garage too.
Question in the back.
Yes, so like in-floor heating, is there a boiler system set up, or how is that operated to heat the floor, the concrete?
So the question is, how do geothermal systems heat concrete floors?
We have the system. We can have a straight water-to-water unit, so we'll take the ground heat and we'll heat water, and typically we'll do that and go to a storage tank. And from the storage tank, you set your temperature in the tank, heat pump will keep it at that. Then your radiant floors will draw from that tank and go to the different zones. So we do have a unit that will do heating, air conditioning, and also make hot water for your radiant floors. So that's all available in one unit. So it is available. Like I said, I've had one in my house for 26 years. So.
You got a solar coming, electric, I should say, EV vehicles. Our garages probably have to be heated, so that may be an incentive coming up. That Efficiency Manitoba should look at that, because if we have EVs coming, which they are, whether it's 2 years from now or 20 years from now, they still will come, and those garages have to be heated because of our winters. So basically, that's why I feel strongly that garages should be included in the Efficiency Manitoba water.
Yeah, I had a couple of comments there. I think predominantly when we're looking from a provincial perspective at serving as many Manitobans as possible, that's why we're prioritizing primary living areas. Garages are not included for that reason. And I can also speak as an EV owner, several years now, moving on to the garage. That's not a requirement at all to fully functionally operate an EV on a day-to-day basis.
Thank you.
For a 12,400 square feet house, what's the, how many ton of furnace and how much length of loop would you need?
So the question is, for a 1,200 square foot home, what size of heat pump would be required and how many feet of pipe would be needed? Are you looking to install one yourself?
Maybe, yeah.
Jerry, this is you.
Okay. 1,200 square foot home, depending on the insulation values, we're typically going to be running about a 3-ton heat pump. 3-ton vertical system. If it's a vertical system, a 3-ton, typically we would install 900 feet of vertical board on a 3-ton system, or three trenches of 600 feet on a horizontal.
So the 3
trenches of 600 feet, can you map that out and do 6 trenches of 300 feet? Like, it doesn't have to be the length of that trench add efficiency?
You meant 600 feet of pipe, sorry, 300
Yes.
feet of trench. There's just some confusion there.
Yeah, no, it's 600 feet of pipe, so it's 300 feet of trench.
Oh, and that's
So-
with the,
Yeah, I like running them straight out and back or whatever, or they don't have to be straight lines, they can be curved or whatever. There's a tracer wire that is run with them too, so that they can be found at a later date if required and stuff.
so to clarify then, you would have 300-foot trenches
Yes.
with 600 feet of.
Yeah.
And again, just to clarify that, these are rules of thumb. Everything requires geological understanding, conductivity understanding, pipe sizing requirements, pump requirements. Yeah, the numbers that are shared here are just to give you a sense as to rough averages.
So from that calculation, I drew that you're about 600 feet of pipe for a ton. Does that sound right, or?
On the horizontal. Yeah.
Okay.
Okay, any final questions?
If somebody does it, the system themselves, do you qualify for the Manitoba program?
Negative.
What was the question?
So the question was, if a homeowner installs the system themselves, do they qualify for the Efficiency Manitoba incentive? And the answer was negative.
So it looks like geothermal kind of works. There's a couple around here and there. Is that true?
That's what I heard.
Okay. And saves money, generally. And we would maybe not use as much natural gas, so our cousins are getting less from us. I guess there's some environmental benefits if they're not using natural gas. So what's the downside?
Downside? We're still waiting, yeah. No, to be honest, the upfront capital cost.
Yeah, really.
The upfront, yeah.
Geothermal is very expensive to install. The upfront capital cost is truly the only downside. And if you're taking advantage of the incentives, they're there to reduce that, right? To minimize that downside. And you have to understand the fundamental difference between using electricity or natural gas and using geothermal. Well, hydro has already built all the infrastructure to supply your house with that. You have to run a line from the street into your house. That's your upfront capital cost there. But the geothermal system, it's all on you. Because hydro is doing it. So you're installing your furnace, your heat pump. So the capital is much more intensive there.
So the issue is that you have to do the upfront capital cost, the same have reduced operating costs. That's on you as an individual building owner, unless perhaps there's a district system that is owned by a geo utility who then operates and sells you access to that loop system.
Yes, and then that system operates then like a hydro system would now. There's no upfront cost for the end user because the utility is taking care of that.
And there's no question that the installation of the ground loop can be deemed as a downside. It's quite invasive, or it can be. With horizontal drilling techniques today, it can be less invasive, but it still takes up a portion of your yard where you can never install a pool, or you have to plan ahead to make sure you're not planning to put a shop in that location. So there's some downsides when it comes to the loop location and working around that for future development. But as far as overall capital costs go, I would agree that capital costs are a obstacle to be overcome. But thankfully, through Efficiency Manitoba and other programs like the Green Equipment Tax Credit, there are ways to overcome those downsides quite easily.
Relative to the downside, I think problem is your wife's not going to get it as nice in the kitchen as she'd like. It's probably the only difference. Everything else is plus. Easily.
Thank you. Question in the back.
You just mentioned another incentive that wasn't mentioned here earlier.
Yeah.
Where does a person find these incentives? From your website?
That's a great question. Thank you. So the question was, I did just mention an incentive that wasn't reviewed in the Efficiency Manitoba slide deck with Lindsay. It was the Manitoba Green Equipment Tax Credit. So for any updated information on incentives, you can always find the most up-to-date information at our website, the Manitoba Geothermal Energy Alliance website, MGEA.ca. And you'll find on that website not only information about the incentives, but also calculations that show if your specific system costs this, what incentives are you eligible for, and how does it break out for your specific scenario.
So cost recovery and stuff?
That is all highlighted as examples. And if when you're going through it, you're not sure, just send an email to the MGEA. It'll come to Fran, or it'll come to somebody else at the MGEA. They'll forward it through, and we'll help you interact with that. We'll direct you to any one of our contractors that can give you that information specific to your property with your costs.
Is there any incentive for the do-it-yourselfers?
Is there any incentive for a do-it-yourself installation?
No, but there's a longer answer, because the reason the MGEA exists is to ensure that all the contractors are operating to a uniform standard, performing quality work, giving you a system that will last for decades. If Joe Blow does his own thing, he's on his own because nobody knows what he's doing. And I think Mike would like to have an input from the back of the room.
I was just going to say, sometimes a homeowner can put some sweat equity in, horizontal gravity to fail with an excavator, or if the neighbor has an excavator, sometimes we like out of the digging. So what to do.
Yeah, a little sweat equity might be different, but the installation must be completed by an MGEA member who is certified.
Okay, so there's no inspectors?
So Efficiency Manitoba requires that an MGEA permit be applied for by an MGEA contractor. So that permit number is required in order to process that application, otherwise it won't get processed. And the MGEA is the regulatory body that oversees installations in the province. So we do inspect systems when required, or when flagged, or when requested to. And so we are the body that oversees the quality assurance program called Proactive in Manitoba.
I like that answer. So you're assuming Joe Blow does a bad job, but if Joe Blow does a great job, can we apply to you to come and inspect it and say,
no.
This qualifies?
No.
So there is a substantial amount of training that is required to be a MGEA member. There are requirements that need to be met in order to get that certification and to become a member. So that's the only process that's available to get these incentives. Thanks for asking.
You talked about horizontal drilling. Did you mean directional drilling?
Correct.
Okay, so is directional drilling less expensive than digging trenches?
So Jerry, do you want to add one? Or Peter?
Depending on the area, it can be less expensive or it can be more expensive. Because the geology is going to dictate whether you can drill horizontally as well. So that's why we ask for individual homeowners go through the process with the contractor, and then we can determine what's the most cost-effective route for you.
Thank you.
So I'll take one final question here.
Yes, what's expected load this year? Like how many units do we expect to put in this year in Manitoba?
Honestly, that answer kind of flips back to Manitobans. So Manitobans have been gifted with these incentives by Efficiency Manitoba late last fall. This spring and this summer, We're anticipating the market to respond in ways that they haven't since 2008 to 2012. And so installation numbers were much higher during that time frame, and now these are the best incentives we've seen in the province. So really, at the end of the day, it's up to all of us as Manitobans to determine where we go. It's early in the season. Many contractors are seeing a large volume of calls and a large number of pre-bookings. I would say it's too early to tell to see where the year is going to end up.
I understand that some contractors are busy right till winter.
Yeah, I mean, Manitoba is blessed with a lot of work. Some contractors are certainly booking up well in advance. Okay, thank you. As we wrap up tonight, I just want to thank our panelists for sharing their time, sharing their expertise, and their insights as far as ground source heat pump installations in Manitoba. Geothermal systems involve several different parts working together, as we've heard tonight. Drilling, system design, installation, long-term operation. It does take collaboration across the industry, sometimes across competitor lines, to make sure that these systems are successful. So we're really grateful for the industry that we have here and the collaboration that we have. We have experienced installers in Manitoba, skilled drilling companies, supportive utilities, which is key, and programs through Efficiency Manitoba that we really want to highlight. I know we've mentioned that quite a bit here tonight, Lindsay, but we really do appreciate Efficiency Manitoba's weight behind this industry to help make geothermal systems more accessible for homeowners. So for homeowners, geothermal represents a proven technology that can deliver comfortable heating and cooling with very low operating costs. And for developers, the same rings true. The interest we're seeing today, even you all coming out and sharing your questions and learning more about geothermal systems, suggests that geothermal will continue to play a really important role in Manitoba's energy future. So just want to take the time to thank you all for coming out and sharing the evening here, being brave and bold and asking your questions and learning. And if you have any further questions about ground source heat pumps or geothermal systems, please reach out anytime to the Manitoba Geothermal Energy Alliance or to any of the contractors or suppliers that are here today supporting the industry. So thank you everyone for coming out. That brings the night to a close.